All right, let's go ahead and take a look at page 533 in your textbooks. And we've been working the last several lessons on finding one missing side of a right triangle if we know the other two sides. Whether we know the two legs, in which case, class, we might need to find the hypotenuse, or maybe we know the hypotenuse in one leg, in which case we would need to find the other leg. Regardless of how we do it, how do we solve for a missing side of a right triangle, class? There we go. C squared equals A squared plus B squared. A formula that we call the Pythagorean theorem. Very good. It's important to remember in the Pythagorean theorem that the letters have meanings. They're not just random letters. What do the various letters mean, Lana?
Those?
The C, the A, and the B. What do they mean?
Hypotenuse equals leg plus leg.
Well, hypotenuse squared equals leg squared plus leg squared. In other words, the C is specifically the hypotenuse. The A and B are the legs. So when you plug the numbers in, make sure if you know the hypotenuse, make sure you put it where the C is. And if you know both of the legs, make sure you put those where the A and B are. Of course, if you know one leg, it doesn't matter which one it goes in for which. Addition's commutative. However, in the homework on page 533, you weren't given a little cutesy picture of a right triangle with two sides with little numbers. You had to figure out where the right triangle was in the picture. Let's go ahead and read number 16 for us, if you would, Joshua. Let's see if we can figure this out.
A water slide with a constant slope starts 110 feet above the ground. If the distance along the ground from the start to where the slide ends is 600 feet, how long is the slope of the slide?
Now it says along the ground. Hopefully that's like along the pool or something. Hopefully it ends in the water. Otherwise that's a really lousy water slide. But did you draw a picture, I hope? Did you perhaps draw maybe a little ladder to get up to a little stand that's really high above the ground, and then down goes the water slide? Now, to be fair, most water slides kind of twist and turn and stuff like that, and maybe have a little bit more of a gradual drop or a steeper drop as opposed to a straight line drop, but that messes with the math, and mathematicians are lazy, so we're going to assume straight line slide. And did you draw a picture like this?
Mm-hmm. Somewhat.
So from where the slide begins to where the slide ends, it says along the ground is how far, Joshua?
600 feet. 600
feet. And then it says the slide is how high above the ground where it begins, Lana?
110 feet.
Good, 110 feet. And the question was, Joshua?
What was the hypotenuse?
Well, it didn't say what was the hypotenuse. It said,
how long is the slope of the slide?
How long is the actual slope of the slide itself? In other words, you're right, Joshua, we're finding the hypotenuse. Did you identify? It's the hypotenuse we're after. And that really, class, that's the whole key, is figure out which of the three sides you're looking for. Is it a leg or is it the hypotenuse? Because if you know it's the hypotenuse, you plug it into the formula, class.
C squared equals 12,000 plus B squared.
There we go. And of course, C squared is going to equal 110 squared, which Joshua, you said is?
12,100.
Right, 12,100. It's 11 squared with 2 zeros after it. And then, Lana, the 600 squared.
360,000.
There we go. It's a 6 squared followed by double the number of zeros, 4 zeros. So 360,000. We'll add those, of course, together to get 372,100. That's C squared. Of course, to find C, the hypotenuse, Joshua, we have to take the square root again. Does this answer seem absurdly large?
Yes.
It's only 110 feet high, and it's only going out 600 feet. 372,100 feet seems absurd. So, and here's the thing, I've had students, even in higher classes than 8th grade, who would leave this as an answer. I'm like, that doesn't even make sense. Think, use your brain. That's crazy. Oh, I forgot to take the square root. So yeah, let's make sure we take the square root. And does it come out evenly? It does. What is that square root, class?
610.
610 foot long water slide. All right, good to go on number 16. Excellent.
My drawing looks almost exactly like yours too.
Well, look at that. That just means you're a great artist if it looks just like mine.
Sort of a slide.
course, we could also draw, you know, the water and stuff. And
Yeah.
Shark. Not wrong.
a shark.
No.
And the water on the slide.
Well, but
That's
of course.
what I did. Just a little drip, drip.
Okay. Anyway, all right. We will leave off our beautiful drawing. Number 17. Lana, read it for us.
A farmer's rectangular cornfield is 15 hectometers long and 8 hectometers wide. The longest row of corn in this field stretches diagonally from one corner to the opposite corner. How long is his longest row of corn?
All right. So, how many of you have ever been driving down the road through a cornfield or a wheat field or cotton field, stuff like that? You know what? And you see rows and rows of plants. Okay. So now this farmer has a rectangular piece of land, but he doesn't plant his rows like this. And you may have noticed that if you're driving down the road, sometimes as you're driving down the road, you can kind of see right out your window. It's just straight down. But usually, as you're driving, you kind of see them diagonally in front of you. And that's the case here, so that the rows are all different lengths. Well, question. How would we draw the longest possible diagonal row?
From the edge to that edge.
Right, from one corner to the opposite corner. This would have to be the longest row, wouldn't it? So that's the row in question. Now it tells us, Lana, that the dimensions of the cornfield again are
1500.
15 hectometers by 8 hectometers, right? And so the question is, how long is this longest row? Is it a leg or is it the hypotenuse?
Hypotenuse.
Once again, it's the hypotenuse we're finding. So again, c squared equals a squared plus b squared. We'll say that that's 64 plus, what's 15 squared?
225.
225. We'll add those together to get
289.
289. Then we'll take the square root of 289. Because again, 289 hectometers sounds ridiculous. And what's the answer?
17.
17 hectometers long, which is 1,700 meters, right? Because hecto means 100, so 1,700 meters long. That's a long way. That's a very, in fact, that's more than a mile long. So a very long.
I guess I
Did
got
not
it right.
get that one right.
Like,
All right.
Except I drew it a little different. I did it like that, but then I drew it like.
Okay, so you started to draw the rows this way and you realized it said diagonal row.
Yeah.
All right.
Yeah, I did not do that.
Does it make sense now with the diagonal rows? All right. Questions on those? All right, before we finish going over the rest of the homework, let's flip over to page 538 where the homework was, but just above the homework section, you see your little review section there. Now, obviously we've skipped the graphing concepts, so that's not something we're going to work, but I do want you very quickly to do 19 and 20, a couple of pure quadratic equations. Numbers 19 and 20.
On which page?
Page 538, just above the homework section. And we're not going to do all of the review. We can't. We didn't talk about graphing stuff, but you'll do the other part, the 19 and 20. right, for sake of time, let's go ahead and take a look at these together. On the first one, Joshua, what did you have to do first?
You had to add 41.
Good. Just like in a normal equation, we're trying to get x by itself. Here we're trying to get p squared by itself. And to get rid of a minus 41, we put a plus 41, which gives us
P squared equals 441.
And of course, once we've got that, we then simply
Take the square root.
of both sides to get
P equals 21.
minus a point.
What?
Minus a point on a quiz or test. Why?
Positive, negative.
Because technically there are two square roots of every number, and since we're not dealing with the length this time, like we are in the Pythagorean Theorem, we do have to use the positive negative. It's something we kind of get out of the habit of, because everything we've done lately has dealt with length, so we haven't needed the positive negative, but this is just a regular equation. We want to make sure we remember that. Did we get the positive negative 21, or at least the 21, and we won't forget the positive negative on a quiz? No, certainly not. Let's take a look at the next one here. Lana, Lana, what do we need to do on this one?
Subtract 26 from this side.
To get?
486.
Well, 3y squared equals 486. All right, then what?
Divide by 3 to get y squared equals 162.
All right, and then
Take this square, but you can't, it doesn't come out evenly.
yeah, 169 would be 13, but that comes out to like 12.7 something probably. And it's just irrational, so what should we do?
You reduce it basically.
All right, how did you factor it?
81 times 2.
Yeah, that actually works out really nicely. 81 times 2, so our answer.
9 times the square root. Positive, negative 9
Ah,
times the square root.
Good, I was about to say
I
minus
had
a
that, I just
point.
forgot to say
Positive,
that.
negative 9 times the square root of 2.
Right.
And do we get this answer? What did you have, Josh?
I got 30 times the square root of 8.
All right, that isn't wrong. Joshua saw that 9 times 18 is 162, so we got 3 times the square root of 18. It's not wrong, it's just not done. Do you see in the 18 there's another 9 times 2? There's another 3 to give you the 9 squared of 2. All right, good. Any questions on those? All right, real quick question. Obviously, we know that if we have a right triangle, we could use the Pythagorean theorem to solve. What if I drew a triangle and I said my lengths are 37, 35, and 12? Is that a right triangle? How would we know if it is or not?
Yeah,
You plug in the
Pythagorean.
Right, then you'd plug the 3 lengths into the Pythagorean theorem and see if it works. Go ahead and check and see, is that actually a right triangle? Or am I a liar? Glenn's like, yeah, you're a liar. That's no right triangle. You're a fraud. Biden. Hey, careful now, Glenn. Let's be careful with our insults. They can only take so much. Chris Christian School does not endorse any political candidate or any political leaning. The views held here are solely the views of the teacher and not the views of the institution in which he works.
Wow.
For the little disclaimer out there on YouTube. We're waiting for our jury to make a verdict here. Yay or nay? Right triangle or no? They're punching numbers into their calculators. And they're eventually, unanimous consent. Yes, that is a right triangle.
You are not a liar.
I am no liar, contrary to what Glenn over there thinks, false accuser. All right, questions on this. Now who's the Democrat? All right, anyway, I'm getting way too political here. Questions on this. All right, go and clear your desk, except for a sheet of paper and a pencil. A sheet of paper and a pencil.
Are you allowed to use calculator?
You are permitted to use your calculator on this quiz, and you are going to be allowed to use the calculator.
We didn't check the rest.
Well, the rest of the homework isn't going to be quiz. The sine, cosine, tangent stuff, that's not on this quiz, so we're going to look at that after the quiz, rather than going over that and getting you thoroughly confused right before a quiz. So let's go over the stuff we're good with here, and go from there. Sheet of paper, pencil. You can keep your calculator out if you want to, and I actually don't know that you'll need it on this quiz, but, if it makes you feel better, more power to you. Clean sheet of paper, I should say, Scott. Let me just keep my cheat sheet out here. Clean sheet of paper, and a pencil, and a calculator. And we will take quiz 42. When you get your quiz, put your first and last name in the name spot, and today's date in the date spot. You can use the pads.
It doesn't have any.
It didn't work any code into the coloring. All right, pull it out.
It's just, it's the last.
Hey, I've seen some really creative students in there.
I have more paper in my locker, but I don't. I've already used my.
All right. Sheet of paper, pencil. First and last name at the top of your paper, along with today's date, or top of your quiz, along with today's date, which is 5/5/21, Cinco de Mayo, or Revenge of the 5th, however you want to put it, or you just say May 5th. As you take a look at your quiz, there are two sides. First side, you've got some addition of radicals. Then we've also got some pure quadratics to solve. Hold on, Joshua, I'm getting there. You're ahead of me. I'm still on page 1. And then we've got some right triangles that we're missing one of the sides. I need you to find it. If you turn the quiz over, you'll see a couple of triangles there where the question is yes or no. Are they right triangles? But I need to see the work to back it up. Don't just write yes or no, but show me work. And you can put a big X through the last two problems. We will not be working those last two. All right, you may begin.